Hello everyone. In today's topic, we are going to talk about irrational numbers. So first, let us take a look at the number system. So the first one is natural numbers or the counting numbers, which starts from 1, 2, 3, and so on and so forth. And if we are going to add 0 and negative integers in here, we are going to have all the negative numbers, 0, and all the natural numbers. So all in all, we have the integers. And if we are going to add fractions and decimals, which can be represented by fractions, we have rational numbers. And if we are going to add irrational numbers such as the square roots and pi, it makes up the real numbers. And if we are going to add imaginary numbers, it will make up the complex numbers. So that's the number system. And today we are going to concentrate on irrational numbers and square roots because we already discussed about rational numbers. So let us differentiate rational from irrational. So it doesn't quite work like this with numbers. So one is inverted and one it is straight. No, it's not. So there are strategies on how to determine whether a number is rational or irrational. So what is an irrational number? It is a number which when written in decimal form, it has an infinite number of decimal digits which appear with no pattern whatsoever. If we say infinite, it does not end. So the formal definition of an irrational number, it is a number that cannot be written as a fraction with integer numerator and denominator. It is non-repeating and non-terminating decimal. So the constant ratio of a circle's circumference is an irrational number, which is given approximately by 3.145 and so on and so forth. And these decimal digits is in 40 decimal points. So we know this irrational number as pi. So it is infinite decimal places, no pattern. There is no fraction equal to pi, so therefore pi is an irrational number. So taking pi in 1000 decimal places, as we can see, there is no pattern. If we have to take a look at 5000 decimal places, there is no pattern. And with the 10,000 decimal places, is still no pattern. So it never ends. It has no pattern. No fraction can be found equal to pi, and pi is the most famous irrational number. So all non-exact roots are irrational numbers. So that is a fact. It can be proven using more advanced maths. But for now, let us have exact samples. So square root of 9, it is rational because square root of 9 is 3 and negative 3. Square root of 5 is an irrational because it gives us non-exact roots. Cube root of 10 is an irrational number because it gives us a non-exact roots. And cube root of 125 is rational because it is equal to 5. 5 times 5 times 5 is 125. And square root of 1/4, it is equal to 1/2. So it is rational. And square root of 25 over 36, it is equal to 5 over 6. So it is a rational number. Now taking a look at the square root of 2 in approximately 1000 decimal places, as we can see, there's no pattern. Taking a look at 5000 decimal places is still no pattern. And taking a look at 10,000 decimal places is still there is no pattern. It never ends. It has no pattern. No fraction can be found equal to square root of 2. So all non-exact roots are irrational numbers. So therefore, square root of 2 is irrational number. So let us look at the 500 decimal places of this number. So is it rational or irrational? Let us see. So as you can see, the digits 0, 1, 6, 3 are being repeated. This decimal has a 60-digit recurring pattern. So therefore, repeating decimals are not irrational numbers. So since we have digits that are repeating, so it is repeating decimals. And recurring decimals can always be written as fractions. So this number, which is equal to 1 over 61, is a rational number because it is repeating and there are recurring decimals and it can be written as fraction. So let us have a summary on irrational numbers before we move on to square roots. An irrational number, when written in decimal form, it has infinite number of decimal digits with no pattern whatsoever. Formally, we define it in mathematics as it is a number that cannot be written as a fraction with integer numerator and denominator. Therefore, it is non-terminating and non-repeating decimals. Examples for irrational numbers, the famous one, the pi. Next, all non-exact roots and the natural number e. So note, repeating decimals are rational numbers. So if the decimals are repeating and terminating, it falls under rational numbers. But if it's non-terminating and non-repeating decimals, they are irrational numbers. Now let's move on to square roots. So let us find the positive and a negative square roots of a number. So if we have a square root of 49, it is equal to the positive and negative 7. Why positive? 7 times 7 is 49. Why negative? Negative 7 times negative 7 equals 49. But if we have a negative symbol before your square root, it is automatically that your answer is negative. So get the square root of 49, which is 7, and then negative, so it is negative 7. But if we have square root of 64, so there is no negative symbol over here, it is equal to positive and negative 8. But if we have a negative before your square root, it is equal to negative 8. So therefore, negative square root of 64 equals negative 8. There are some facts of square roots. The first one, given that square root of a squared equals a, then a squared is a perfect square. So perfect squares are the numbers which if we are going to multiply 1 times 1, it is equal to 1. And if we are going to extract a square root of 1, it is a whole number. Then 2 times 2 equals 4. So 4 is a perfect square. 3 times 3 equals 9. So 9 is a perfect square. 4 times 4 is equal to 16. So therefore 16 is a perfect square. And so on and so forth. There are a lot of perfect squares. And the second one, if a is a real number and a is less than equal to 0, then a squared, the square root of a squared, equals the absolute value of your a. So if we have a negative number here, it is less than 0. So negative 6, the square root of negative 6 is squared. It is equal to the absolute value of your number inside the parenthesis. So square root of negative 6 squared is equal to 6. And square root of negative 8 squared, it is equal to the absolute value of negative 8, which is equal to 8. Now let us have the third one. The square root of negative numbers are impossible to determine. So if we have a square root of negative 6, it is undefined. Square root of negative 8, it is undefined. Take note, the square root of negative numbers are undefined. It is impossible to determine. And the fourth one, all non-perfect squares give irrational results. So if the number inside the parenthesis is not a perfect square or non-perfect square, therefore the result is an irrational number. So square root of 10 equals 3.1622 and so on and so forth. And the square root of 24 is equal to 4.8989 and so on and so forth. 10 is non-perfect square. 24 is non-perfect square. So if we get the square root of it, it gives an irrational result. And square root of 0 equals 0. Those are some facts about square roots. Now let us apply those concepts about square roots in determining the values of the following. So first one, square root of 729. So 729 is a perfect square. So it is positive and negative 27. Then we have a square root of 36 over 441. In doing this so, get the square root of 36 first, which is equal to 6, and get the square root of 441, which is equal to 21. So therefore, the answer is positive and negative 6 over 21. Now let us have the third one, square root of 0.0064. We all know that 64 is a perfect square. So therefore, from that, it is zero point 0.8 and then we shall add a 0. So it is equal to positive and negative 0.08. Now let us have the fourth one. It is a mixed fraction. So therefore, we are going to simplify first, converting it to improper fraction, which is equal to 2 times 9, 18 plus 7 is 25. So square root of 25 over 9. And the square root of 25 is 5. And the square root of 9 is 3. So we have positive and negative 5 over 3. Now let us have another one. Negative is square root of 0.09. We all know that the square root of 0.09 is 0.3. And since we have a negative before the square root, the answer is negative 0.03. Now let us have example number 5, square root of negative 11 over 8 to the second power. So in here, we just need to have the absolute value of this number. So we have 11 over 8. And for number 6, we have a negative symbol before your square root. And this one, we just have the positive or the absolute value, so 0.5. Since there is a negative here, the final answer is negative 0.5. Now let us solve for the following equations. Given that x squared is equal to 36, in here, to get rid of your power of 2, we are going to extract the square root of it, okay? So both sides will be extracted. So in doing this so, we can cancel the square root symbol and the power of 2. And the square root of 36 is positive and negative 6. So therefore, x is equal to positive and negative 6. Now let us have another one. Square root of x squared. So in here, don't touch your left side, okay? Or your right side, I mean. All you need to do is to eradicate or cancel your square root and to the power of 2. And charan, x is equal to 0.13. And our last example is square root of x equals 11 over 10. In here, we are going to get rid of your square root. So therefore, we are going to square the left-hand side of the equation as well as the right-hand side of the equation. In doing this so, we have this one, square root of x to the second power equals 11 over 10 to the second power. So in here, we can cancel the square root as well as the to the second power. So x equals to 11 times 11 is 121. 10 times 10 is equal to 100. So x equals 121 over 100. So now for your practice, do your worksheet 3 in the Google Classroom. And that's it for now. Thank you for watching. See you again next time. Bye.